Welcome back, everybody. Moving on to the next section in Chapter 11, our chapter on 3D shapes. Okay, in 11.3, we're still talking surface area. Now we're going to move on to two new shapes, pyramids and cones. Okay, objective to find the surface area of pyramids and cones. Now, hopefully what you see with this is just like finding the surface area of a prism and cylinder was basically doing the same thing. Same idea with a pyramid and a cone. The equations for these are going to be basically the same. All right, so let's define a pyramid for you right off the bat here. Now, the picture that comes to your head when I say pyramid, which hopefully just looks like this, okay, that's really all we need for a definition. We'll go a little bit deeper than that here. I'm going to say a pyramid is a polyhedron, so 3D shape, in which one face, the base, can be any polygon, so we have the base on the bottom, and the other faces, the lateral faces, are triangles, because we have lateral faces that meet at a common vertex. Okay, so we have our base, which can be any shape. Now, typically, we'll just do square bases, okay, but it could be anything. Lateral faces are the triangles along the sides, and the vertex is where they meet at the top. Right now, here's where things get a little tricky for the pyramid. We have actually two heights we're going to be dealing with. I'm going to say the height of a pyramid is the perpendicular segment from the vertex to the plane of the base. So in other words, the height goes from vertex to the base at a right angle. Height's going to drop straight down the middle of this pyramid. But then we also have the slant height. We usually write that as a funny looking L, is the length of the altitude of a lateral face of the pyramid. In other words, is the length of the triangle, or the height of the triangle, on the outside of the period. Okay, so the height drops straight down the middle. The slant height drops down the side, okay, with a right angle to the side. Reason we need both of those is one we're going to use for finding volume, which we'll get to in a few days. The other one we're going to use for finding the surface area, which we're doing today. Okay, so there will be a little bit of solving and moving back and forth between the two. All right, now before we get into giving you the equation for the surface area, let's take a look at where that's coming from. So this is in my virtual manipulatives tab again. So there we go. I've got some equations floating around there I need to get rid of. Okay, we've got a 3D pyramid that we can take a look at. And we've got our base and we've got our slant height down the side. Now let's take a look at what happens when we unfold this guy. Okay, we end up with 1, 2, 3, 4 triangles and a square to find the area of. Okay, so as far as the formula goes, the square at the bottom, that's just the area of a square. We'll call that B. And then for the lateral faces, if I look at finding the area of a triangle, it would be half times base times height. Okay, where base is a side length of this triangle. Okay, height is that slant height. That's why we're using this. And I can get all those at once if instead of just using one side, I do the whole perimeter of this shape. Okay, because if I add those all together, okay, each of those bases is just going to be the perimeter of my base there. Face go away here quick. All right, so this formula is going to be very similar to what we did with prisms. Okay, I'm going to say the formula for lateral area is half times P perimeter of the base times L for slant height. Okay, half because we're talking about triangles. Perimeter of my base is going to make up kind of basically all the bases of these triangles, and then times L, the slant height. If I do that, that's going to give me the area of these 4 triangles on the sides. Okay, then for the actual surface area, we'll just say surface area equals lateral area plus B. Now with prisms, it was 2B because we had 2 bases. With the pyramids, it's just B because we have a single base. All right, so let's go ahead and use that formula. We said that lateral area is equal to 1/2 times perimeter of the base times the fancy L for the slant height. So let's fill that in. We've got 1/2 times perimeter of the base. That would be 6 plus 6 plus 6 plus 6. I'm just going to say 6 times 4. That's my perimeter of my base. And then times the slant height, the height along the side of the triangle. And when I multiply all that through, I end up with a 120. Okay, so the combined area of all the triangles along my sides, my lateral area, is 120. Okay, from there, we said that surface area equals lateral area plus 2b. Whoops. I lied, not 2b. We just mean plus b. Okay, plus single b because we have one base. That's going to be one of the big tricks for not mixing up pyramids and prisms, is it's 1b instead of 2b. Okay, so lateral area 120 plus area of the base. Now the area of the base is just this square on the bottom. Side length is 6, so we can just say 6 squared. So in other words, 120 plus 36, that's going to give us a 156 meters squared. All right, so problem 2 now. Part A, let's say find the lateral area and surface area of the pyramid. So same idea. Now the difference with this one is if you pay close attention, notice this time they gave me the height down the middle. All right, but what I need to find the surface area is this L here, this slant height. So I can't jump right into my equations. I actually have to solve for that first. Okay, to do that, what I'm going to do is I'm going to make a right triangle out of the height we know, the slant height, and then this half a side length here. It's not going to be the whole 30. It'll be half of 30, which would be 15. Okay, for that, since I have a right triangle, I can use Pythagorean theorem. A squared plus b squared equals c squared. Okay, where the a and the b are going to be the 15 and the 36.4. That's going to be equal to our slant height squared. Okay, now these are going to give me some ugly numbers to work with. So what I'm just going to do is I'm just going to square root both sides. And that's going to give me my slant height on the right. That's going to be equal to this 15 squared plus 36.4 squared. And I'm just going to plug that into my calculator in one shot here. So calculator is pulled up. We'll go second square root, and then 15 squared plus 36.4 squared. All right, now if you don't have a graphing calculator, you're just going to have the square root with a parenthesis here. That's okay. But what I want to show you is instead of doing a whole bunch of extra calculations, I can let my calculator do all the work. And I'm going to say that gives me a 39 point, we'll say 369, we'll say 370. And since that's an intermediate answer I'm going to be using later, I'm going to round that to 3 decimal places just to keep things looking nice, or keep things as accurate as possible as I go through. And then once I have my slant height, we're back to where we were with the first problem. I can find my lateral area, which is half times p times the slant height. Half times perimeter of the base times slant height. So in other words, half times perimeter of my base will be 30 times 4. Okay, times the slant height, the 39.370. When I plug all that in, I get a 2,362.2. Split this up a little bit. And then my surface area will be my lateral area plus b for the one base. So in other words, 2,362.2 for the lateral area, plus for the area of my base, square with a side length of 30, that'll be 30 squared. All right, when I add all of that together, I get a 3,262.2, we could say meters squared. Okay, so there's an example of a difficult pyramid problem. That's really as hard as we can make it, just making you solve for that slant height right off the bat. Tell you what, part B is the same idea. I want you to take a minute, pause the video, work through that question, then hit play to check your answer out. All right, so let's run through this one quick here. Again, we know the height. We don't want that though. We need the slant height. We need this guy here. So we're going to break this problem down into a right triangle with the height, with half the length of the base, and this slant height here. Okay, half the length of the base, if I divide the 5 in half, will give me 2.5. So for Pythagorean theorem, I can set up 2.5 squared plus the 10 squared is equal to the slant height squared. If I square root both sides of that, that's going to leave me with slant height is equal to a 10.308, we'll say, rounding that intermediate answer to 3 decimal places. All right, from there we can find the lateral area, which is half times perimeter of the base times the slant height. So in this case, that'd be half times 5 times 4 for the perimeter of the base, times that 10.308 we just found for the slant height. When I multiply that all together, I get a 103.08. We'll just leave it 2 decimal places, what my calculator gave me. And then to finish up, surface area then is the lateral area plus the area of the square base. So in other words, 103.08 plus area of my base. Length is 5, so area would be 5 squared. When I multiply all that through, I end up with a 128.08. I'm just going to say 128.1 meters squared. Okay, next thing we're going to talk about is finding the surface area of a cone. Now, just like we could think of a cylinder as a circular prism, same thing here, we can think of a cone as just a circular pyramid. Okay, technical definition, I'm going to say it's a solid that has a circular base, a vertex not on the plane of the circle, and a curved lateral surface. Okay, so instead of triangles, we have curved surfaces here. So again, we have a circular base, we still have a vertex, we still have a slant height, we still have a height. Okay, difference is our base is a circle instead of something else. Now for a surface area formula, this will be a little different. If I look at the net, I won't get triangles. But if I take my cone here and open it up, look at the chunks I end up with. Well, I have a circular base, so there's my b in the equation. And then this lateral area is kind of like finding a triangle, but it's also basically finding a sector of a circle, a larger circle, with a diameter, a radius of the slant height. Okay, so a little trickier to see, but basically what I want you to see here is it's the same formula. Okay, just instead of triangles, we have this kind of sector, which is like a triangle. All right, so we'll approach this the same way. Lateral area of the cone is going to be a half still, k times 2 pi r. Now 2 pi r is the circumference formula for a circle. In other words, the perimeter of the circle at the bottom, so we can think of this as a p as well. Okay, times the slant height. All right, or you could cancel out the 1/2 and the 2 to get rid of that part, but I like to think of it as a half times p times l once again. Surface area then is the lateral area plus the area of the base, so that's still LA plus b. All right, so let's go ahead and use that formula and find the surface area of a cone. Okay, first off, you got to ask yourself, did I give you the correct height? This one, no, I didn't again. I gave you the height. What we need is the slant height. So first thing we need to do to solve for that, using this triangle with a side length of 10, side length of, I'm going to say this 13 is the diameter because it's pointing at the center. So side length of 6.5 and the slant height. So for that, I'd say 6.5 squared plus 10 squared is equal to the slant height squared. We'll square root both sides, and that's going to leave us with a slant height equal to, we could say 11.927. All right, lateral area is half times, I'm just going to say p for perimeter of the base, times the slant height. So in this case, that's going to be half times, Now, perimeter of the base, we're talking about perimeter of the circle, in other words, circumference of the circle. So for that, we could use 2 pi r or pi times d. I'm going to use pi times d because we have the diameter instead of radius. Okay, and then times the slant height once again. Okay, so for this one, we'll have half times pi times 13 the diameter times that slant height we just found, the 11.927. All right, now as far as should I leave this in terms of pi, not in terms of pi, I'm going to say don't worry about it in terms of pi with this one, just because this is an ugly number anyways. My answer is going to be ugly no matter what, so we might as well just multiply things through. So we'll go half times pi times 13 times 11.927, and that gives me a 243.6, we could say, for the lateral area. And then from there, surface area is equal to lateral area plus the base. Okay, so lateral area plus, we're talking area of a circular base, that's going to be pi r squared. So we could say the lateral area, the 243.6 we just found, plus pi, I'm just going to divide this off here, times the radius 6.5 squared. Which when I just plug this all straight into my calculator, again, not in terms of pi, multiply the pi through, we get a 376.3 centimeters squared, we could say. Okay, last problem for the day, part B, same idea, finding surface area of a cone. Why don't you take a minute, pause the video, give that one a shot, and then hit play to see how it's worked out or to check your answer. All right, let's go through this one. And once again, right off the bat, I've got to solve for that slant height. Okay, you won't always have to do this, but we're getting used to it here, I suppose. I can say that 16 squared plus 12 squared, that's my a and b squared, is equal to the hypotenuse squared, the slant height squared. I'm going to take a square root of both sides. I end up with a nice number this time. Slant height's equal to 20. And that's going to make my calculations easier for this one, obviously. All right, lateral area is equal to 1/2 times perimeter of the base times the slant height. So in other words, 1/2 times perimeter of this circle here. I'm going to say 2 pi r since I have the radius, the 12. And then times the slant height we just found, the 20. And then with this one, since these are all nice numbers, I'm actually going to get a nice number in terms of pi. So I'm going to leave the pi out of this one. If you multiply by pi, that's okay. You could always divide it out at the end. When I go 1/2 times 2 times 12 times 20, that gives me a 240 pi. And nice looking, so that's why I left it in terms of pi. And then for the surface area, we have the lateral area plus the base. All right, so in other words, that 240 pi we just found plus the base, which is pi r squared again, so pi times 12 squared. Oops, sorry, 240 pi plus pi times 12 squared. So we could write that as 240 plus, pi plus 144 pi for the 12 squared pi. And when I add the two of those together, I get a 384 pi. All right, now if MathXL asks for the answer in terms of pi, we can leave it like this. Otherwise, if we want to round the answer like we did with the last problem, just multiply 384 times the pi, and that'll give us a 1206.4, we could say. And either of these would work as an answer depending on what the question is looking for. All right, so there you go, finding surface areas of pyramids and cones. Hopefully what you're seeing after all that is a pyramid and a cone are pretty much alike, so finding their surface area is very similar. And then also hopefully you're seeing that this isn't much different than the prism and cylinder stuff we were doing in the last lesson. it all kind of goes together pretty nicely. Okay, so once you start getting good at one or two of these shapes, the rest of them are going to be a breeze. Give the homework a shot, work through it, and like usual, if you need help, make sure you're asking for help.